Okay, so Phil's walked us through a hypothetical example of how you could apply GIST to the development of an enterprise ontology. Now I'm going to step you through a case study of how we've actually been implementing and extending GIST for one of our clients. I want to first start out by saying that GIST is really versatile, as you maybe got a hint of when you heard about the kinds of disciplines Phil and Michael and I have been working in. So at Semantic Arts, we've applied GIST to all of these disciplines and industries. So there's a wide range here from financial services to healthcare, pharma, regulatory compliance, manufacturing, and even, as you'll see at the bottom, digital humanities, which might come as a surprise to you because GIST bills itself as an upper enterprise ontology. And it certainly came as a surprise to me, but I have a digital humanities project I work on, and I was surprised to see how well suited GIST is to serve as an upper ontology in that domain as well. So this is a list of our clients, and aside from a couple of examples, GIST is being used as part of the semantic stack at all of these clients. And obviously that covers the range of industries you just saw in the previous slide. So I'm going to focus now on one particular client. And this is a professional services firm. It's a mid-sized firm of about 1,500 people. And they specialize in research projects in a range of disciplines, basically STEM disciplines. So there are scientists, economists, statisticians, engineers, and so on, doing research at this company. When we started here, they gave us a PDF with their long-term data strategy, and it really read like a data-centric manifesto, we were pleased to see. So they wanted to create an enterprise-wide data model in order to make data interoperable. They wanted a central governing body to ensure that that shared data model is maintained and doesn't drift back into separate silos. They wanted to be able to apply analytics across functional areas, meaning, of course, that they need a unified data model in order to do so, so that the data connects across those areas. They wanted to reduce dependence on particular tools and information systems so that when an information system gets retired, they want the data to stand on its own and persist. And they wanted the data to be on-prem in particular as well. They also, it's also a consideration to reduce dependence on individual developers. So they have a couple of developers that really have many integration hubs in their heads where they've connected all the data together, but you don't want to be dependent on individual people. You want the data to speak for itself and be natively connected. And of course, they wanted to create data that is fair, findable, accessible, interoperable, and reusable, basic principles we're used to thinking about. So the client data cuts across a number of different domains. What you see on the left side is the horizontal domains. So these are things you'd find in almost any company of this size. Finance encompasses, for example, corporate budget and billing and payroll. And HR includes recruiting, hiring, benefits, compensation, and so on. So again, these are things you'd see everywhere. The things on the right are the verticals that they operate in. So as I've said, it's a professional services firm, and they do STEM-related research. So at Semantic Arts, we've developed a methodology that we call Think Big, Start Small. And what this does, it allows clients to migrate towards data centricity one subdomain at a time. And at each step, you realize something of value. So you have something concrete that is giving you value. So the Think Big part is at the enterprise level. So we start with a single unified model of all the information at the company And this will form the scaffolding that you use to add more projects incrementally. The start small is the individual business domains and subdomains. So each new project or domain that you take on extends the model and adds more data sources, more data to the graph. But all the domains remain united under this high-level enterprise model. So without the think big portion, you'd have a bunch of separate small domain models and data, possibly more data silos. Without the start small side, you'd probably be looking at several years of effort before any practical value was realized. And that would probably be so intimidating that you wouldn't even want to get started. So we've developed this think big, start small strategy in order to give you the advantages of both having a global overview of where you're going and concrete value every step of the way. So what did this look like at our client? Our initial project, as with many of our clients at Semantic Arts, was a proof of concept. So we developed 3 domain ontologies. We installed a free triple store. We got CSV exports from relational systems. We converted that data to RDF to populate the ontology. We loaded it into the triple store, and we took the competency questions that we'd elicited with the help of the subject matter experts, turned those into Sparkle, ran them, and they could see, the client could see the results, and they were, in this case, extremely excited. So we went on to the next step. They purchased an on-prem enterprise triple store. We worked with their developers to refine the model so that it could accommodate all the nuances of the data, which we may not have covered in the proof of concept. Their developers built a pipeline to automate the data mapping and loading. We currently have 5 domains in the knowledge graph, and the client has been building small applications that run our queries and display the results either in text or graphics. And this product is about to be released to the firm as a whole. And the dark blue indicates where we have been, the point at which we've completed work. So this medium blue indicates where we are today. We are extending the knowledge graph to a number of other domains. And the steps we're looking forward to in the light blue are that the knowledge graph will become a source of truth for some, at least, of their data. So we'll add the two-way flow, whereas right now we're just pulling data into the knowledge graph from their other systems. This next step will involve pushing into it as that data gets integrated in the knowledge graph and then gets pushed out to other systems, and therefore the knowledge graph itself becomes the source of truth in some of these domains. And finally, we want to start replacing legacy systems with applications that are built natively directly on top of the triple store. And of course, that makes that makes the knowledge graph even further the source of truth when that data is not actually, it's being edited directly in the knowledge graph. It's not actually being edited in external applications. And this is what gives them that persistence that they want, and ultimately not relying on these external information systems. Throughout the process, of course, we've had to socialize the knowledge graph, and what this has meant at various stages is from the very beginning, as I've said, we developed models hand in hand with their subject matter experts, and we elicited competency questions. We demoed the POC to their executive team, research management, who were very excited and wanted to continue. In the productization phase, we conducted tutorials with the developers at the client site, who we're going to be working closely with on the mappings and querying and testing the knowledge graph. And as I said, they're rolling that out imminently to the firm as a whole. And employees they won't have immediate access to the knowledge graph because they still haven't implemented a security system on top of the graph. But what they're doing is building small applications and dashboards on top of the triple store to be able to answer these competency questions. And employees are actually submitting questions to the team to write new queries and develop new dashboards. And then again, in the final phase, we'll be working on building data-centric, low-code, no-code applications with their dev team. And all along, we've been also working with their data governance committee on defining a process for extending and updating the model and making sure that things remain in sync across the enterprise. Okay, quick look at how we got started at this client. So the original plan had been to start with finance domains, but as we started talking with them, even at the very first meeting, it became clear that they had a lot of unanswered questions and were struggling in some ways to successfully manage their projects because they couldn't answer certain questions or because some of their concepts were not well defined. And so it became clear that where we really needed to start was with research projects and then sort of fan out from there to other domains that touched on projects and project management. And the goal that we had in mind always was to help them, help provide them with these analytics that they so desperately needed so the project leaders in research management could manage projects and keep their budgets on track. So with each new domain, we brought in another data set and sort of supplied another piece of the puzzle. So the initial competency questions were things like this. Have we delivered what we promised to the client and on time? Is my project on budget? How well does staff planning align with actual hours that were charged? I'm looking to start a new project. How do I find the researchers at the company who have the expertise needed to work on this project? How much of my project funds have already been obligated as time charges, travel expenses, and so on, but not yet paid out? So you can see that, again, this focus on projects and project management that we took initially. So then looking at how we implemented the start small part of the project, again, research projects are at the very heart of what they do. And along with that, research products, which are the actual deliverables, the outputs of these projects that they give to their clients. And so we modeled out those. And then in order to answer some of the questions, for example, that I showed, such as, have we delivered what we promised and on time, we had to model the project proposals and the agreements that they'd actually made with clients and compare those to the research products that they had created. Time charges are the major expense that's charged against projects. So we needed, in order to help them answer questions about whether projects were on budget, we needed to model and integrate data about time charges. And we, at the same time, built in sort of a slice of HR data at the same time in order to connect people to time charges and projects and products that they've worked on. And that helped us answer that competency question about how well staff planning aligns with actual time charge. So the dark blue, again, is the things that we've already done that are already in the knowledge graph. The medium blue is what we're currently working on. And again, the bottom two are focused on budget tracking of projects. So these are charges that are also made against project budgets. So they needed this input as well. Continuing to build out HR will get us into areas of researcher expertise. So based on, let's say, educational background or other projects they've worked on or products they've worked on, that will help us answer that question about finding researchers to work on particular projects. And then we will, at that point, we'll sort of have this research support totally in place, and we'll be fanning out to more of the corporate ops domains that don't directly tie back to project management, but obviously are of great concern to the company as a whole. Okay, so I've talked a lot about our methodology and how it supports client goals and long-term strategies, and now I want to turn to looking at GIST and some concrete examples of how GIST played a role and has been playing a role in helping us build the client ontology and meeting their goals. So how does GIST do this? What are the properties of GIST that we find really useful? So it unifies data by providing a set of shared concepts or framework, conceptual framework, both in terms of classes and properties. And that's an essential step in creating interoperable data. Many of us have been talking about this. We think GIST is at the right level of abstraction. So many of the upper ontologies we've looked at are kind of philosophical in orientation, very abstract, and it's hard to actually apply that to real client data in the real world. So we think that GIST is abstract enough to be able to fit a lot of client concepts underneath it, but not so abstract that it's not clear how you would start working with it. GIST encapsulates some common modeling patterns for reuse, and the examples I'm going to show will illustrate that. If you align your concepts, the client concepts, with GIST concepts, for example, by making the client concepts subclasses of GIST classes, that ensures that you're doing semantic modeling, that your classes have valid, they represent a single concept. So we have 152 classes in our client ontology, and every one of them is a subclass of a GIST class, occasionally more than one. And my rule of thumb is that if you can't find a superclass in GIST, there's a good chance you need to rethink your model. We think that GIST gives us quite full coverage. Of course, we know GIST is always evolving, so it's not perfect. If you find something that simply doesn't fit into GIST, you can propose it to us through one of the mechanisms that I'll tell you about later. But I think it should be kind of a red flag if you can't fit that concept into GIST. Finally, we have 20 years of experience developing GIST. There's no need for you to reinvent the wheel. This gives you a leg up, a jump start. You can develop better ontologies faster. And, there really isn't any other industry in which you consider starting everything from scratch. So it's just natural to start with an upper ontology. So let's look at some concrete examples of how we applied the GIST conceptual framework at this client. So one of the very first things we noticed is that the client used the word project in a number of different ways, and even the same person would use it in different ways. And I actually remember asking at one point in our first meeting, what do you mean by project? And everybody started looking at one another, and nobody seemed to quite have the answer. So we found that they were using it to mean a research project. They had something they called a finance project, which is essentially just a bucket of money that you use to pay expenses. They would use project to mean a project proposal, and they would also use project to mean the agreement with the client on the work to be done. So this is where the idea of aligning classes to GIST classes to ensure that you are doing good semantic modeling helps out. So if we had taken this term project, this concept, or this term project with all its various meanings and decided, okay, we're going to have a class called project, that wouldn't have had any semantic integrity. And one way we could tell that is that it wouldn't have lined up with any GIST concept because it meant several different things. So by looking at through the GIST conceptual framework, this sort of helped us tease apart these different meanings and put them into that conceptual framework. And this also gave us a jump start by using the GIST classes and properties and relationships for each type of thing that we eventually identified. So a research project quite naturally became a subclass of GIST project, and we expect, therefore, that like other projects, it would have people assigned to it and a specific work plan, and maybe it would have sub-projects. Those are all things that a GIST project can have. The proposal became a subclass of what we call intention in GIST, and this finance project became a subclass of account, which is, you know, something that has money in it and that gets drawn from as expenses are charged. And then finally, the client agreement became a subclass of what we call, of what is in GIST, a GIST agreement. And an agreement, we know from GIST and our experience with GIST, has parties. It has typically start and end dates, and it states exactly what work will be done. It's an agreement between the client and the vendor. So a couple of examples I'm going to go through show how GIST encapsulates reusable modeling patterns. So we have a class in GIST called temporal relation, which is, I find, extremely useful. It's used to model information about relationships between two or more entities, such as dates and times, could be other contextual information. And, you know, given that RDF star and Sparkle star are not well supported by tooling, and RDF and OWL reification are terribly cumbersome and verbose, we think this is the best way currently of modeling the context or the complexity about relationships. We have a number of date properties that we can apply to a temporal relation for both planned and actual start and end dates. And we have this sort of top level abstract property, just has participant, which you can use to point to the two or more things that are involved in that relationship. You might, in fact, end up defining more specific properties or sub-properties of this one if you want to indicate more specifically what that relationship is. Okay, so what kinds of client temporal relations did we find at our client? A lot. So they have thematically based research portfolios, collections, essentially, of which a project could be a member, but in a time-delimited way. We have participation of a department in a project, which was also time-delimited. And then assignments is a big one. So an employee gets assigned to a position or to a department or to a project. A laptop gets assigned to an employee. Status values get assigned in order to capture workflow. And by putting dates on them, you can track the evolution of that workflow. So here's one example of a temporal relation that we implemented at our clients. So this is blue here is the client concepts, and orange are the GIST concepts, properties and classes. So here's just temporal relation over on the right, and we defined a class task assignment as a subclass of that. So right away we have the planned and actual start and end dates available to us, and we decided in this case to define some more specific properties. In particular, since the assignment can point to two different types of people, an assigner and an assignee, obviously you have to have different predicates to distinguish those roles. And the planned versus actual start dates were really useful because we could use that. If you remember, there was a competency question about staff planning and how well it aligned with actual assignments. So this was a good way of looking at assignments and comparing planned and actual dates. Okay, another really useful class we have in GIST is called category. And this is used as the basis of building taxonomic classification and introducing and integrating it into an ontology model. So we've defined two predicates, has broader, which is transitive version, and has direct broader, which is not transitive. We use those to build the hierarchy of concepts. And then we have a property is categorized by, which it can apply from anything to a category. And we use these categories, I think Phil has also mentioned this, in places where, I mean, it's a way of assigning a type, but in cases where you don't have full semantics such that you want to define a class, or you have a lot of concepts and you don't want to define a lot of classes, or you don't want to define a highly nested hierarchy. So this category is just a way of labeling or tagging or putting things into buckets without a lot of semantics. So here's an example we used at our client. So they had a large taxonomy already of research areas that encompassed hundreds of concepts and 3 to 4 levels of nesting. So that hierarchy, that taxonomy was built using just has direct broader, and research area was defined as a subclass of category. And then we could use that category to categorize all sorts of things, from project proposals to projects themselves, research products, people. And you can see that this allows us, using a single taxonomy, and this predicate allows us to address the question of how do I locate the expertise I need to do my research project. So I'm looking for a person with expertise X for my project, which requires expertise X. Okay, and the final example I have has to do with GIST magnitudes. So prior to GIST 13, a magnitude in GIST was composed of two things: a number, numeric value, and a unit of measure. So it was things like 25 pounds, or 8 hours, or $500 an hour, or 40 hours a week. And that looked like this, schematically speaking. And ovals in this case I'm using to represent instances, and the orange ovals represent parts of GIST control vocabularies. The green is just instance data. So that's what a magnitude looked like in GIST prior to GIST 13. Now, the client the thing you need to answer with magnitudes is you can't just have magnitudes. You need to be able to express what attribute of something is actually being measured by this magnitude. And at our client's site, at this point, just didn't really provide a uniform approach to doing this. So we ended up doing this in a number of different ways. So we define, GIST actually defined at that point certain subclasses of magnitude, GIST duration, for example, being one. And we also defined other subclasses, such as monetary per duration for something like $50 an hour, duration per duration for something like 40 hours a week. And then we also defined specialized predicates like has plan duration. So in this case, we're trying to express the fact that I'm planning that my meeting will last for 8 hours. So we were a little bit all over the place with the subclasses and the predicates, and there was not a single uniform way of representing what magnitudes we're measuring, what feature or characteristic of something was being measured. So then GIST 13 was released this past summer, and Phil entirely rewrote the model, the GIST model of magnitudes. And among other improvements, we now have a uniform way to model the quantitative aspect that's being measured. So in the new GIST 13 model, a magnitude is composed of three things: a numeric value, a unit of measure, and what's new is an aspect. So a magnitude now means something like billing rate of $500 an hour, or planned duration of 8 hours, or time allocation of 40 hours a week. And what this did was provide us with a uniform way of answering that question: what is it I'm measuring? We don't have to worry about specialized predicates or subclasses anymore. We just have one thing to worry about, which is an aspect. And in this case, I've drawn that planned duration as an aspect in blue because that's defined in the client ontology. A lot of times you will find that aspects are client specific. But we also have defined in GIST reference data, which I'll briefly talk about later. We do have a large number of predefined aspects that you can use as well. And notice that, all the other client-specific stuff has gone away. So all we have is that planned duration. We just have the one predicate has magnitude that we use to connect to all magnitudes. Okay, the other thing I want to mention before wrapping up this section of the talk is that at Semantic Arts, we've developed a number of GIST extensions across a variety of disciplines, which you can see on the right. These extensions right now, unlike GIST, which is a publicly available open source ontology, these are private and not publicly available, that we make them available to our clients. And we found at this particular client that drawing on these provided additional benefits in specific domains. So obviously, as I said, we have HR, we're going to have payroll, we have computing, we've already worked with software licenses, and we have professional services, of course. So all of these things, these GIST extensions provide a mid-level of abstraction between GIST and the nuts and bolts of the client ontology. So it's just yet one more leg up in your ontology development. Okay, so in the final section of the talk, I'm going to briefly discuss how you can learn more about GIST and how you can get involved in the evolution of GIST. So one place to start is on our website at semanticarts.com, and we have a page devoted to GIST. You'll see about midway down that page, we have something called the GIST Forum, which meets once a month. And we do various types of presentations at that forum. We do tutorials. We introduce new features that are coming up, or we discuss with you the possibility of new features so that you can have input into those. So you can sign up for the GIST Forum on that link that's circled in red. And I encourage you to do that to stay connected with GIST and how it's evolving. And we have a playlist on YouTube of the previous GIST forums if you want to catch up. I think one of the best ways to get involved with GIST is through our GitHub repository, which again is a public repository. And I'm sure most of you work with GitHub and you understand what features it has. So one of the best ways to get involved is by looking at issues that we're discussing and adding your own comments and thoughts to the discussion threads on those issues and even on pull requests. You can look at our release planning, which we do as GIST projects, circled there on the upper right, to see what's coming up in the next version of GIST. You can, of course, see the entire GIST history, the current release, previous releases. And internally at Semantic Arts, we conduct bi-monthly meetings of the development team, and those notes are stored on the wiki. So if you want to see, again, the types of things that we've been discussing, you can find that there. We also have, in addition to the RDF files themselves, of course. We have a lot of documentation. We have a style guide and instructions about how to contribute to GIST should you want to submit a pull request to this repository, and information about how we manage our releases and change management, and a lot of other information. An additional GitHub resource we have, and I mentioned this earlier, and this was again put together by Phil, who hand in hand with his new GIST 13 magnitude model created this remarkable repository of GIST reference data, which includes units of measure and the aspects which you've seen. It's got a lot of data in there, and it also includes queries to help you pull out the data you need for your project. So again, you don't have to reinvent the wheel. Everything is defined in terms of the classes and predicates that are in GIST 13. So, you know, this is a great resource if you're developing with GIST. A couple of other GitHub resources worth mentioning. Peter, who spoke yesterday about GIST, has developed a really nice ebook, which a new edition comes out with every major release of GIST. So you can put this into a Kindle and read it there. It includes diagrams, and it also organizes our concepts thematically. So in sorts of things that kind of cluster together are organized together in the book. We've also fairly recently come out with a GIST BFO alignment. This again is a public repository. And so if you have a need or a desire for a BFO compliant ontology, but are unsure how to get started with BFO because it's one of those ontologies I mentioned that's very philosophical and abstract, and you think GIST might be easier to work with in the kinds of ways that I've been demonstrating, then we've developed this mapping so that you can import GIST and import BFO and then import this bridging ontology and start working with GIST, and your ontology is automatically BFO compliant and built into the BFO infrastructure. Okay, so to wrap up, I just want to go through and summarize the key points from our two talks yesterday and today. We talked about how using ontologies to model the real world rather than the internals of applications makes meaningful and interoperable data. We talked about how upper ontologies can help you create a uniform enterprise-wide ontology to connect disparate data sources. We talked about the fact that GIST is lightweight, business-friendly, well-maintained, and at the right level of abstraction to give you real practical guidance in developing your ontology. We've shown you the best way to get started building an ontology from GIST, starting with the early stages of a partie and competency questions and moving on to fit your concepts under GIST. And we've provided an in-depth look and specific examples of how GIST can help you model concepts in your enterprise in a uniform way that creates interoperable data. And again, it's key to think you don't have to reinvent the wheel. We've done so much of that work for you over the last couple of decades. And we've discussed resources to get started and or continue your education in GIST. And finally, we encourage you to get involved through the GIST GitHub repo and the monthly GIST forum. So how to get started. We'd love to help you implement GIST in your organization. We think we're pretty good at it. And the way to get started is through this email address here. So get in touch.